Assalamualaikum to everyone. This video is about solving the question of assignment part 2, work and energy and impulse and momentum. Our group members are Muhammad Firdaus bin LAINDON, Muhammad AZLAN bin KIRNO and Fawwaz Asyraf bin Muhammad Fakri. Okay, first, the question asks to sketch the free body diagram. Where F is the force, N is the normal force, and W is the weight of the object. So the next question asks to calculate the speed of the object just before it leaves the surface at B. So we need to utilize the principle of work and energy. So this is the equation where m is the mass of the object, VA is the velocity of the object at point A, plus W. W is the weight of the object, mass times gravity. AY is the difference of the height of the object between A and B. Then VB is the velocity of the object at point B. So we substitute the values in the equation. So the value that we obtain is 7.0036 meter per second. So question 1C, calculate the distance from the wall of the ramp at B to where the object strikes the ground. So we calculate the horizontal direction of the positive axis. Then we use the kinematic equation. Next, we put all the input given to the equation. So we got two unknown, which is D and T. So we conclude that this is the first equation. Next, we go through the vertical direction for y-axis. We use this kinematic equation. Then we put all the given input into the equation. So we obtain the value of t is equal to 0.2381 second. So this is the second equation. Next, to find the value of d, we need to substitute equation 1 into 2. We need to substitute equation 2 into 1. Put the given input into the equation. So we obtain that the value of d is equal to 1.3335 meter. So for question 1D, compute the speed at which the object hits the ground. So to solve this question, we need to use the equation principle of work and energy. Then we put all the inputs into the equation. The value of AY is equal to 3.5 meter. Then we obtain the speed of which the object hits the ground is equal to 8.2867 meter per second.
Okay, so for question number 2, we assume that if y naught is 0 in part 1, we assume that y naught is 1 meter in part 2. So for the question A, calculate the velocity of the object just after it rebound from the ground. So we are using this equation Vay square equal to V1y square plus 2ac SAY minus SY1. So VAY square equals to VIY square is 0 plus 2 AC is negative 9.81, SY is 0 and 3.5, and we will get 68.67 VAY square, and we square it will become 8.2567 meter per second. Will be facing downwards. The velocity after the ball is rebound will be, we are using the equation E equals to Vg square minus Vay2 over Vay1 minus Vg1. E will get from the question is 0.7 and Vg square is 0 minus Vay2 over our Vay1 is this one. We got a negative 8.2567 minus Vg1 is 0, and we will get Vay2 will become 5.8 meter per second facing upwards. For the question number B, we will be using the conservation of momentum in x direction. So positive in x direction, and the equation is m v1x equals to m vax. So our vax we will get 7.01 meter per second. This we get from question number 1. So the rebound velocity of the ball at A is Va2 equals to 7.0101I plus 5.8J. We'll be using the in vector form. And the equation, the kinematic equation for vertical motion at ball after rebound will be V2y square equals to Vay square plus 2ac S2y minus SAY. Our V2y is 0, Vay is 5.8 square plus 2 AC is negative 9.81. S2y is our h, when minus SLY is 0. So we will get 0. 5.8 square is 33.64. This one will get minus 19.62 H, and our H we will get 1.7145 meter. That's all. Thank you.